Experiment 3. Aim. To study the dependence of current, or I, on the potential difference, or V, across a resistor and determine its resistance. Also, plot a graph between V and I. Apparatus required. DC voltmeter, ammeter, given resistor or resistance, battery, connecting wires, rheostat, plug key, sandpaper. Theory. According to Ohm's law, the potential difference, or V, across the ends of a conductor is directly proportional to the current, or I, flowing through it if other conditions and temperature remain the same. V is directly proportional to I. V is equal to IR, where V is equal to potential difference, I is equal to current, and R is equal to resistance constant. Procedure. Clear the ends of the connecting wires with sandpaper. And remove the plug from the one-way key. Now, connect the battery, ammeter, voltmeter, and rheostat as shown in the circuit diagram. Now, connect the voltmeter in parallel to the resistance. Now insert the plug key to check the deflection in the ammeter and voltmeter. This shows that our circuit is correctly connected. Now, adjust the slider of the rheostat to adjust the reading on the voltmeter as 1 volt. Keeping the arrangement same, measure the reading on the ammeter. Take out the plug key and record the values of the current and the potential difference. Now again, put in the plug key. Now, adjust the slider of the rheostat to adjust the reading on the voltmeter as 1.50 volt. Keeping the arrangement same, measure the reading on the ammeter. Again, take out the plug key and record the values of the current and the potential difference. Repeat the experiment 3 more times for different values of potential difference, that is, 2.0, 2.50 and 3.00 volts. Observation and calculations. Looking at the table, we can compute the values of resistance by using the values of potential difference and current by the formula V upon I is equal to R. In the first case, the value of resistance is coming out to be 1.53 ohms. Second case, it is coming out to be 1.50 ohms. Third case, it is 1.48 ohms. Fourth case, it is 1.47 ohms. Fifth case, it is 1.50 ohms. We can find the mean value of resistance as 1.53 plus 1.50 plus 1.48 plus 1.47 plus 1.50 all divided by 5. This comes out to be 1.49 ohms. Graph between V and I. Now let us draw a graph between V and I. We can draw the graph by plotting ammeter reading I on the y-axis and plotting the voltmeter reading on the x-axis. This is how the graph will look like. It is a straight line. It can be clearly seen from the graph that V is proportional to I. The slope of the graph gives the value of resistance R. Result. The result of this experiment is, from the graph, we can see that graph with V and I is a straight line. The value of the unknown resistance comes out to be 1.49 ohms. Precautions. The connections should be tight and clean. The current should not flow for a long time. The rheostat of low resistance should be used to change the current smoothly. Connecting wires should have negligible resistance.